Hi, this is a video about this video, which I'll be correcting and updating here, so you should probably watch it first for context. It's a bit over an hour long, but it's anything but padded, and as you can tell from this addendum video, its content probably warranted a bit more time to explain. Also, if you're just here for an update on chat reporting, here's a timestamp to go to. Lastly, thanks to the billion of you in Binary who've already watched it before me even making this video. It's like I get to do my own university lecture, but it's on everything but the curriculum, and over 2/3 of the class leaves after hearing my voice for 30 seconds. To start this video, I've initially missed a few details in the first video regarding Minecraft's updates, which I'll go over now. 1.9 actually changed a bit more than adding elytras, mending shields, and trapping mobs in boats. It also changed the physics of these boats, for better and for worse. First, boat elevators instead sink the boat immediately, severely nerfing their vertical mobility, but boats on ice, and later blue ice, now have horizontal speeds rivaling even the elytra. Personally, I don't think the boat's vertical mobility needed to be nerfed, though I do think the horizontal speed buff is actually pretty nice, and could be somewhat balanced since the infrastructure to let the boat go that fast usually needs to be built beforehand. The problem here is that elytras, especially after 1.11, can go just as fast, both vertically and horizontally, and require almost no infrastructure aside from maybe a simple sugarcane and creeper farm, far outclassing boats in almost every way. Keep in mind, the massive buff to horizontal mobility wasn't even an intentional design choice, it was a glitch in the 1.9 snapshots that Mojang kept because everyone liked it so much. Still, good on them for keeping it. We could use a bit more listening to the community these days. Anyway, because the elytra and fireworks aren't really that hard to get, and can even be less effort than setting up minecart rails or finding a horse and saddle, this level of power creep can be further demonstrated by pig riding, a transportation method so outclassed and obsolete that I completely forgot to mention it at the time, so thanks to the very helpful individual who pointed this out to me. The strider riding added in 1.16 could also be added to the obsolete transportation list, though it at least has the merit of having a useful niche if you ignore the existence of elytras. This is likely why most SMP servers disable elytras. Since then, I've been told that most SMPs actually do the opposite of this, so I guess this must have just been a trait of the servers I've seen, though the elytra does pose a different problem for SMPs. With its speed, you can force the game to generate and load new chunks much faster than many servers are equipped to handle. If the game was optimized better for this rate of terrain generation and chunk loading, this problem wouldn't be nearly as bad, but...
Java sucks. Don't make games in Java. Like Marcus keeps telling you Java is amazing and the best. No, don't. Just get Unity.
While I briefly touched on this in the original video, I didn't fully realize just how much poorly optimized code exists within Minecraft Java, and most of it isn't even from Notch. Though Minecraft's original code was never the most optimized to begin with, a lot of it has actually been rewritten, meaning many of Minecraft's modern performance problems may actually come from the recent code made by Mojang. Now, to know where Mojang first went wrong, you'll need to know how applications like Minecraft internally store the data they use while running. The most basic interpretation of application memory is as a massive array of objects called bytes, each having 256 states they could be in. In hardware, these bytes are commonly composed of 8 bits with 2 possible states each, commonly found as a circuit that could be either off or on. A byte's state could represent anything the application needs, such as a generic number, block or entity data in Minecraft's case, or even a pointer to another location in memory. Much like how 8 bits form a byte, anything with more than 256 possible states can be encoded in the combined states of multiple bytes, letting a computer store almost anything. The computer's processors also keep small amounts of data separate from memory, known as registers, which is where the application's calculations are done, but they hold too few bytes to store much on their own, so most data is still kept in memory and just copied to a register whenever a calculation needs it. To keep track of where everything is stored so the program can actually access what it needs, and to ensure the program doesn't try to store multiple things at the same memory location, 2 main data structures are used, known as the stack and the heap. The stack first reserves a large section of memory and a single register to store a pointer to the start of that memory, with the rest of the application's memory going to the heap. When a variable is made in the stack, its data is stored in the memory location pointed to by the stack's register, and the location stored in that register is moved ahead by the variable's size to point to more free memory. When the variable is no longer needed, the pointer moves back by the same amount to point to the free memory at the new end of the stack, though this does come with the limitation that data could only be removed in the opposite order it was allocated in, much like adding and removing items at the top of a real stack. Also, because of the stack's limited memory, storing too much data could move the stack pointer into the heap's memory or even cause it to roll back to the start of the stack, either way resulting in a stack overflow where the program attempts to store data where it really shouldn't be doing so don't do it. Instead, for larger amounts of data, or anything that can't be allocated and deallocated in the specific order mandated by the stack, the heap is used. Unlike the stack, the heap can allocate new data anywhere with enough consecutive free memory, though it first has to actually find the free memory, making it slower than the stack, plus the extra data to keep track of which sections of memory are currently in use by the program. Likewise, freeing allocated data requires altering the stored map of the heap's memory, which is generally slower and more complicated than just subtracting a number from a register. And that's assuming you remembered to free your data when you were done with it, because if you didn't, then you've just caused a memory leak. And yes, all that unused data will just sit there and accumulate until you either close the program or your computer runs out of memory. While most programming languages nowadays replace manual memory freeing with a process known as a garbage collector, which periodically checks for and frees unused data automatically, the very existence of this extra process can make using the heap even slower compared to that of a lower level language. Now, garbage collection does have some performance benefits. Languages like Java are more optimized towards large amounts of heap usage than C++ by default, though in return, low-level languages like C++ will grant you much greater abilities to optimize object allocation for your use cases if you're willing to do so, and garbage collection and the heap are nowhere near as bad as I've so far made them out to be, just as long as you use them correctly. First, use the stack instead whenever you can, meaning in C++ you may use more data-oriented approaches to inheritance or replace vectors with consistently small max sizes with arrays. In C# you might replace smaller classes with structs to store them on the stack. And while Java has no C# struct analog, you can still break up smaller classes into their contained value types, which are individually stored on the stack at the cost of messier code. Second, if you really have to allocate data on the heap in a performance-sensitive application such as a video game, whatever you do, don't make a bunch of really small allocations. Not only is it terrible for speed, but memory usage too, since the heap usually has to allocate more space than you need due to alignment restrictions and how the memory map is stored. And it's also terrible for speed and memory usage a second time because the memory map may need to grow to store data about all the tiny sections of memory you just made. Instead, merge lots of small allocations into fewer large allocations, and for expanding containers, it's generally a good idea to allocate a bit more than you need, such as reallocating about 1.5 times a container's current size when running out of space. Finally, don't make a bunch of really small deallocations either. If you really need a bunch of small objects and can't easily put them in a larger block of memory, put the unused ones in a list instead of deallocating them, and overwrite them before resorting to allocating a bunch of new ones. Though this caching strategy may not improve performance in every circumstance, you can always test and benchmark it to see if it's right for your... Oh look, it's Mojang. Do you have something to share with the class, Mojang? Oh, so ever since 1.8 Java Edition, you replaced every single function using 3 integers for a block coordinate with a block pos object that's allocated on the heap because it's Java? And you blindly followed industry standards by making them all immutable with no regard for the garbage collector or allocator, so an operation as basic as adding 2 Cartesian coordinates together requires 3 separate heap allocations for the resultant operands before immediately discarding the operands? Then you do realize that just iterating over the blocks contained in a single chunk means going through over 98,000 blocks. Wow, and now the garbage collector has to clean up over 200 megabytes every second where it previously only had to deal with 20 at most? So with Java's default memory limit of 1 gigabyte, the game has to run a complete garbage collection, entailing scanning that very gigabyte worth of memory to find and free the literal millions of block pos objects you just allocated and immediately discarded every 4 seconds? And now Minecraft has lag spikes? What an unforeseeable consequence. And from what I've found, this is far from the only time Mojang prioritized over-engineered industry standards over performance. Many places where there once were a few simple operations now contain a sprawling mess of factory objects and type conversions, all with their own little heap allocations. Because of all the programming languages that would fall victim to this ridiculousness, it had to be Java, the one that stores almost everything on the heap. I guess you could even say that blindly following industry best practices with no regard for actual performance is considered harmful. Seriously though, I could be a fan of storing every remotely related group of variables in a comically over-engineered class too, since it greatly increases code readability if you do it right, but that's why I'm using a lot of C++, which is really good for that because it optimizes the abstractions away when it compiles, and then it stores the variables on the stack where they should be. Stack. Since researching for an hour-long video can take a while, and the chat reporting situation changed quite rapidly when I was editing the video, it's no surprise that some of the info I used in this section was already somewhat outdated when the video released. And I may have also gotten some information wrong to begin with, sorry about that by the way, but I'll be correcting those mistakes in this section. I've also recently seen some other people's solutions to fixing various problems in Minecraft, though mostly chat reporting, so I'll also go over the ones I've heard about and show why I still think the best bet for saving Minecraft is giving it as much competition as possible, and how you may be able to help with doing so. As it turns out, Minecraft Bedrock's single-player bans, Java's chat reporting, Java's realms bans, and the swear filters actually differ a bit more than I originally thought. While the only thing that changed since my video is the chat reporting, my original take on the other problems could use some slight corrections and clarification. First, the swear filter isn't only in Bedrock as I originally thought. It's also in Java Realms servers, though unlike in all of Bedrock, adult accounts can actually turn it off. Also, the automated monitoring and global bans for chat messages, books, and signs across all of Bedrock and Realm servers on Java are completely different from chat reporting, which only works on chat messages, is implemented across all of multiplayer for both Minecraft versions, and is reported manually, though I'm personally still somewhat skeptical of whether Mojang's actually willing to spend the resources to keep manually reviewing every report, or whether they'll try to push automatic chat monitoring on more parts of Java Edition in the future. One other important distinction is that, at least for now, the bannable offenses in chat reporting don't include milder categories like swearing, while doing so anywhere with chat monitoring can still get you banned, or if you're on Bedrock Edition, even shadow muted so you don't even know that you've been punished. And yes, that does completely defeat the point of a punishment. Now for the chat reporting, because that's still likely all anyone actually cares about, Mojang is still handling it quite terribly. As of now, just about the only conclusive thing they've said is that they're going to do everything in their power, which right now is quite a lot considering they do own Minecraft, to make sure chat reporting is here to stay. Meanwhile, most of those affiliated with Mojang who haven't kept silent have either openly mocked chat reporting dissenters, which seems rather immature, or alleged that rather than this being the work of Mojang's higher-ups, the game's chat reporting was actually pushed by one reclusive community manager who remains unnamed, though I'm personally rather skeptical of this explanation. It seems rather odd to me for any one community manager to have this much power, and the alternative explanation that Mojang or Microsoft is pushing this to project a more family-friendly image for the game seems significantly more likely. Of course, we're only reduced to speculation on the reasoning behind chat reporting because of Mojang's radio silence on the matter. Maybe they think if they don't say anything, then most of the community will forget about the changes, and considering how internet outrage usually works, they're probably right. They've also changed how chat reporting is implemented to fix some of the exploits people have created for it, which is kind of a plus. Since I don't feel I've explained the technical details well enough from the first video, I'll go over them again before telling you what they've changed, and how the exploiters continue to remain one step ahead. Before chat reporting, chat message data sent to the server contained little more than the plain text of the message, which the server would then forward to the other players along with information on who sent it. This means the server could also fake a message sent by anyone, which wasn't much of a problem until chat reporting was implemented, which had to ensure that nobody could fabricate a message sent by another player, else abusers of the system could report anyone for saying just about anything. To accomplish this, message data now comes with the time it was sent, information on who sent it, and some randomly generated data known as a salt, which are then combined with the plain text of the message and a number called a private key, specific to and known only to the sender's account, to calculate the message's signature, using math operations that are much easier to calculate in one direction than to solve for the other. This means that it's easy to sign a message with your private key and to verify that a message's signature is correct using a public key known to all the other players, but calculating an account's private key from a message and its signature is practically impossible, so the ability to sign a message with your private key can prove that it was you that sent it. However, this meant that nothing stopped exploiters from omitting messages in their reports or fabricating their own messages to drastically change the context of a conversation, so Mojang worked on a new way to verify chat messages. In the second version of the chat reporting system, a message's signature was now calculated based on previous messages, ensuring the signature would be invalid if they were omitted. To make this work, data was sent to all players on a server whenever a player sent another a private message, though only the recipient still knew its contents. However, this now meant that nothing stopped exploiters from using this data to find whenever anyone on the server sent a private message to someone else. And while they could no longer modify a conversation's context retroactively, whether a message appeared as private or public could be altered afterwards without invalidating the public key, meaning people could still add messages from themselves by just privately messaging themselves during the conversation, or hide anyone's messages afterwards by making it appear as a private message to someone else when sending it to Mojang. To my current knowledge, this exploit has not yet been fixed by Mojang, though they have done more than their fair share of denying that it exists in the first place, and the same exploiters have certainly been hard at work themselves, having made a server-side version of their gaslighting mod with even more power to fabricate conversations. They've also recently discovered a bug in the game that can kick everyone from a server if they join after your public key expires and you send a message in chat. Because if there's one sign of a well-made update, it's being able to make a server completely unplayable with a single chat message. And it hasn't even been a full year since you could take over both the computers of everyone on a server and the computer running the server with a single chat message. Naturally, there now exists a mod to tell you exactly when your public key will expire to make it even easier to temporarily lock out a server. Also, the mods made to take advantage of these exploits were called Gaslight, Gatekeep, and Girl Boss, which is a pretty funny prank by the developers. Naturally, with the chat reporting system this bad, there have been quite a few attempts to get it removed from the game in some way or another, so this is the point where I'll go over those I've heard of and rate how effective I think they may be at solving the problem. The first proposed solution is to disable chat reporting with mods, and I think this is actually a pretty good solution for Java Edition players, at least for the time being. Since these mods have already been made, all a Java Edition player needs to do is to get the mod and their game client will go back to only sending the plain text of their messages. And if a message lacks a signature verifying you sent it, you can't be reported for it. Otherwise, the door would be open for people to fabricate anyone saying anything. By default, Minecraft servers won't let players connect if they do this, but this setting can be changed, and a lot of servers have already done so. In addition, mods exist for the server to disregard the extra message data and only send other players the plain text of the server message, formatted like a player chat message. Thus, if either the client or the server have the mod, chat reporting becomes effectively disabled. Of course, this doesn't work for Bedrock, any Java servers who haven't changed the setting, Realm servers, or accounts that have already been banned, and doesn't solve the other problems I've talked about in these videos, but to its credit, this solution isn't trying to. The next proposed solution is to create a community-run authentication server to bypass Mojangs, and I think this sounds kind of illegal. While the fact that a paper somewhere says you can't do something will never stop everyone from doing it, and I could be wrong about the legality anyway due to not being a lawyer, this solution shares almost every limitation with the first while being slightly harder for a server to implement than changing a setting, and unlike the mod, hasn't even been made yet. Still, since the only thing Mojang does to prevent globally banned players from joining servers is to have Mojang servers refuse to authenticate them, effectively telling the Minecraft server the account's using invalid login information, bypassing the authentication servers in any way would allow a banned player to connect. The third proposed solution is to bolster Minecraft's competition so either Minecraft improves or its competition improves beyond Minecraft, and you could probably already tell I personally still think this is the best long-term solution, though it's not without its pitfalls either. First, the only thing with enough quality to even begin to compete with Minecraft is Minetest, which I reviewed in the previous video, and while it's actually better than Minecraft in some aspects, one niche game engine is nowhere near enough competition to affect the largest video game in human history, and its engine's limitations prevent it from capturing every niche Minecraft appeals to. Now, I don't actually think this is too much of a problem. One of Minecraft's flaws that I previously listed is how it attempts to appeal to everyone and fails, but what can appeal to everyone is having more games and game engines of Minetest's quality or higher, as each can target a specific niche, and in doing so, target it much more effectively than Minecraft ever could. For this, we need as many attempts to be made as possible, as it can only lead to more competition, which is inherently a good thing, though it will take time, making this a more long-term solution than the others. That's also not to mention whether enough people are willing to get behind a completely new game when most are all too quick to dismiss such projects as Minecraft clones, but I'm not talking about making Minecraft clones here, there's already enough of those after all. I'm talking about exploring the untapped potential of a budding genre that has been practically monopolized by one game for a decade, a pretty good game mind you, but a monopoly nonetheless. I'm talking about a whole genre of mine-likes, short for Minecraft-likes, or more accurately, Infiniminer-likes, because if you want to dismiss any game as a clone with no regard for the obvious differences between it and its source material, why not start with Minecraft itself? Besides, the peaceful protests haven't worked, unpeaceful protests would be stupid and almost certainly accomplish even less, popular people calling attention to it, but mostly clickbaiting it, barely did anything, exploiters broke it repeatedly and still didn't get it removed, and modders removed it from parts of Java, but Mojang still has almost complete control over Bedrock and nothing stops them from going ahead with other things the community hates. I still think the only long-term way to force a company to do better is to go for their wallet, and it may require that enough people are able to make something on par with Minecraft, and that enough people are willing to play it, but the alternative is a monopoly, and as with any monopoly, you're bound to see a decline in quality sooner or later. While I think raising awareness of why chat reporting sucks is important, it's not going to matter if it's the only thing anyone is doing. A Save Minecraft Discord server exists, but I've recently joined it and the only solutions I've seen them rally everyone to try are the occasional protests, watching videos from popular people saying chat reporting sucks, but anyone who bothered to join the server should already know it sucks, and a change.org petition. Did you know the server's actually constantly losing members. I'm not trying to make fun of it, I like the server and I think it's a noble effort, but that change.org petition could have 1 billion signatures and Mojang still doesn't have to care about you, and people will leave the cause if they feel there's nothing more they can do to help, which is a shame because I really do like Minecraft. Speaking of watching videos from popular people on Minecraft's flaws and alternatives, after my last video was done and I didn't have to worry about accidental plagiarism anymore, I decided to watch a few myself to see if they had covered anything I missed, including the non-understanding floating point guy's Minetest video, and it actually mentioned stuff about Minetest that my video didn't. Though one thing it barely gives examples of for some reason are any of Minetest's survival Minecraft alternatives, which are likely the main thing anyone coming over from Minecraft would want to know about, so that's an odd decision. Still, decent video, and definitely better than
chaos. I don't know what to say chaos. I've got explainable.
Well guys, I removed this funny G from my startup config and I got an out of memory exception. Did I just break Minecraft? Absolute chaos. There are no words in the English language to describe this out of memory exception. Speaking of floating point, I think I might have simplified my original explanation a bit too much, so I should clarify that most floating point formats use a radix of 2 rather than the 10 used in scientific notation, which makes calculations faster because computers store numbers in base 2. Floats also reserve their most significant bit as a sign bit, which is separate from both the exponent and mantissa. Anyway, that's been all the information I know about the chat recording system at the moment, and unless something big happens or I ever feel like remastering my old videos, I likely won't be making any more videos on the subject since I don't want to milk the topic. Also, it would just be boring. However, I will likely create future videos expanding on the last part of this video, the devlog for my own Minecraft alternative. In the last video, I introduced the voxel game and game engine that I've been working on. Since that video, there's been a lot. Starting shortly after joining the Save Minecraft Discord server, I found another Discord server detailing the development of another voxel game running parallel to mine. After the same server was found by the lead developer of yet another voxel game in progress, I made a separate Discord server for all the voxel game programmers to go to instead. That way, information about potential developing Minecraft alternatives could be consolidated to just one place, and people looking for alternatives to support could find which one suits them best. If you want a better long-term Minecraft replacement than the games found in Minetest, or just want more competition to exist so Minecraft may eventually improve, I'd recommend checking out the 5 projects currently featured on the server, since it is currently the best source of information and links for them. One I personally think seems the most promising is Groundborn, led by the 3rd guy to join the 1st server. And yes, I'm well aware that isn't exactly the best vote of confidence for my own game. Speaking of my own game, I also realized that not dropping a name or logo just means I'd be forced to wait until enough of the game is finished to make a proper trailer with the reveal, lest the name drop be a massive anticlimax after waiting so long, and one of the other games doesn't even have a name yet, so the interim would probably just be really confusing, thus I've just put it here. Anticlimax aside, you're probably wondering how development has been going, since this is supposed to be a devlog, and if you remember this brief note from the first video, you'd know there's been a lot to catch up on, so rather than try and fit it all in this devlog, I'll try and spread all the info about its development across multiple devlogs before hopefully catching up with the present once the game is in a more fully demonstratable state. My project was originally developed as a tech demo to see how clean and optimized I could make a voxel engine, using mostly C++ and as much of my own code as possible, though I made my first prototypes for the various methods of voxel rendering and storage in C# with Unity for faster testing to see which were the best. After Minecraft's recent decline in quality, the focus of the project soon shifted to making a long-term Minecraft replacement I could feel happy playing, since that same optimized voxel engine could be potentially leveraged to satisfy just about all of my criteria for a perfect voxel sandbox survival game. This was, of course, not before the many rewrites and refactors I did to the game engine to get it this way, and as of now I'm still going. Most of those older versions are deleted now, so I don't have much to show of them, and admittedly I probably should have bothered to have at least some form of version control, but I can give you an idea of just how many times I rewrote even the most basic features during that phase of development, with a few examples. How about storing a 3D Cartesian coordinate? Something so basic you'd be surprised that the last time I had to rewrite how I did it was still well after the release of my last video. The easiest way to do this is to store each axis in a separate variable, which you'd know from earlier is also the fastest way to do this in most programming languages. A slightly cleaner way to do this in C++ is by making a struct to store each axis' variable together, and by storing a constant size array in the struct and using templates, this Cartesian vector, not to be confused with the most popular container in the C++ standard library, which is also called a vector but isn't really that good for actually storing a vector, can now be generalized to store any class or have any dimensionality because of how templates can make a new vector struct for each combination of class and dimensionality used. Now it could be done, but this could still be so much easier to access. So for my vector, I added an operator override to access the vector like an array rather than using its member array, added some operators commonly used on arrays such as dereferencing, and templated all the other operator overrides to enable performing nearly every operation component-wise, some of which also used variadic templates, basically templates with a variable number of arguments which you can then put into a function. Here, the templates are used to make a new function for each combination of vector classes used in the operation, and variadic templates are used when the number of arguments is unknown. Of course, this still doesn't work when operating on a vector with a scalar, so I made a templated implicit conversion from any scalar value to a vector of any size filled with that value, made a copy of each component-wise operator to work with a scalar so they don't have to count towards the one user-defined implicit conversion per argument to the function or operation limit, which is important if the class the vector stores relies on implicit conversions for its operators. I also want to make the operator overrides non-member functions for scalar left operands. At this point, the member array is already private, so my now generalized vector could act as a strictly better constant-sized array. But if I can't access the first 4 elements using x, y, z, and w, then it's no longer as easy as it could be to use it as a vector. I didn't want to just use public member variables and keep the private array for the other values because some of those variables shouldn't be present in vectors with lower dimensionalities. And the only way to conditionally include a variable based on its class's template is to use partial template specialization to rewrite the entire class for that specific template value. So I just added x, y, z, and w as references in the hope that my compiler could optimize them out of the struct due to their addresses being constant relative to the vector's starting address. It can't, and the references may have caused issues with the default move and copy constructors, but I didn't know that second part at the time, so I just defined the constructors manually. After a day of research where I tried to see if there was anything cleaner than redefining the class 5 extra times, I unfortunately had to redefine the class 5 extra times. Though I did find I could use an anonymous union to allow the vector to alternatively be indexed as R, G, V, and A, just like the vectors in most GPU languages. This works because a union stores values at the same point in memory at the cost of only being allowed to use one value, in comparison to structs and classes which store values sequentially. I then added a constant static vector where each element was its own index in the vector and new functions to shift or rotate vector elements, before finding out the constant variable can't be declared because I didn't set any of my functions as constant expressions, so I can't use them to generate the constant variable. After declaring all the necessary constant expressions, I found that this didn't work either, since the cleanest and fastest way to access vector elements after I had to change the variables around was using pointer conversions of somewhat dubious levels of C++ standard compliance, and my compiler rightfully wouldn't let me use that in constant expressions. After experimenting with a few potential solutions, including this pointer arithmetic of extremely dubious levels of C++ standard compliance that my compiler actually did let me use, I found a solution that actually makes the class less complicated for once. I can't have private members in an anonymous union, but by making the entire vector a union and defining the letter variables in an anonymous struct, thus moving the private array back to the start of the struct rather than an element number 4, I can go back to indexing the vector with the internal array rather than relying on dubious pointer conversions, letting me use it in constant expressions due to its full standard compliance. As a bonus, there's no longer a vector size where every letter variable is present but the array at the end isn't, because the array isn't at the end anymore and is present at every size, meaning I can get away with only 4 extra class redefinitions instead of 5. Unfortunately, I had to offset this newfound lack of over-engineered complexity by rewriting the class's constructors, because I wanted scalar to vector conversions to be implicit, but I shouldn't have that if converting the scalar's class to the class the vector contains is supposed to be explicit. Likely to try and avoid the mostly needless complexity I'm about to partake in, C++ won't actually let you declare an explicit and implicit version of the same constructor simultaneously. But this is C++, so you can easily circumvent this, even though Stack Overflow says you can, by adding any template to the implicit constructor and having no template on the explicit one. Because non-templated functions override templated ones and you can't call a constructor by its template due to the language's syntax, the only difference between the constructors becomes that the explicit one cannot be called implicitly and thus must fall back to the implicit constructor, thus letting you run different code for whether a constructor was called explicitly or implicitly, which I use for vectors to call a constructor of the contained class in the same way. Because my vector constructors already use templates, I exploited the similar rule that variadic templates are always overridden by non-variadic ones, merging merging parts of my scalar to vector and vector to vector constructors with a variadic constructor, I already added place to construct a vector from a set of elements it should contain. It may be confusing to read, but it makes the constructors a lot more intuitive to use if scalar to vector conversion is just an extra, optional step after user-defined implicit conversion. And I shouldn't have to touch the internals of my vector class anymore anyway, unless I want to add more support for const classes in a vector or using a vector as a multidimensional array. Also, due to how C++ allocates things, my class with all these features runs no slower than the simple design I started with. Unlike, let's say, if someone tried to do what I did but worse and on Java, a language which we've established really doesn't work well with a bunch of small templated classes due to allocating almost everything in the heap. A good thing no one did that. While this class is the most basic part of the engine and is thus much more likely to be polished until it has enough outward ease of use to make even the toughest programmer shed a tear, its full source code and total development time would probably be enough to make the same programmer shed several tears for an entirely different reason. So now that my game's development has more priorities than just fast and nice to use code, I likely won't be doing anywhere near this level of over-engineering or micro-optimization, unless I get particularly bored one day and I feel like doing it, since I might actually want to play a release of my game sometime this decade, and I'm going to need a bit more than just a performant engine for that. However, if you are somehow interested in hearing more stories of all the over-engineering and micro-optimization I already did, then let me know, though my fixed-size vector class was by far the most extensive case of it. In the meantime, stay tuned for my next devlogs, where I may talk about replacing integers with my own fixed point class because they annoy me, how Vulkan isn't such a bad graphics library once you get past the 18-page guide and thousands of lines of code needed to draw a triangle, or maybe even something actually pertinent to game design. Thanks for watching this far. Most importantly, have fun, and class dismissed.